Hi, this is Jo Karen Hudson. I'm going to work with you today on section 14.2, the quotient rule, and adding and subtracting radicals. For any non-negative real numbers, x and y, the nth root of x divided by y is the same as the nth root of x divided by the nth root of y. Now, example 1 will make that a little clearer. This is saying that if I have a fraction written under the radical, I can actually separate this into the square root of 25 over the square root of 49. And the square root of 25 is 5, and the square root of 49 is 7, so I can get an answer real quick for that, 5 over 7. Example 2, I have negative the cube root of 27 over the cube root of y to the 9th. So my answer is going to be negative. I'm going to use this program on the calculator to get the cube root of 27. Cube root of 27 is 3. And remember how we do the variables? We divide 3 into 9. It goes evenly. So the cube root of y to the 9th would be y to the 3rd. Final answer on this one. The square root of 50x cubed divided by the square root of 2x squared. I could write this under one radical and you could see that it would reduce. You may be able to see that it will reduce without doing this step, but it's very easy to see how it will reduce if you do this step. 50 divided by 2 is 25, and x cubed divided by x squared would just give you x. And then I know that what the square root of 25 is, it's 5, so I will just have 5 square roots of x here. Square root of x will not break down because the index is 2, the exponent is 1, and 2 doesn't divide into 1 evenly. What are like radicals? Now we had this in Mod 10. Like radicals have the same index. They have the same radicand. That's what's underneath the radical. Only the coefficients differ. So let's look at some like radicals. 4 square roots of 2. This is a square root, this is a square root. They have the same index. Square root of 2, square root of 2, they have the same radicand. Only the coefficients differ. This coefficient is a 4 and this coefficient is a 3, and they differ. These are like radicals. Let's look at the next group. They're both square roots, so they have the same index. They have the same radicand, same number under the radical. The coefficient of this one is the 4. The coefficient of the second one is the -1. So the coefficients do differ. These are like radicals. These are both cube roots. They have the same index. They both have the square root of 7. This is a 1 and this is a 1/2. These are like radicals as well. Adding and subtracting radicals. Simplify radicals wherever possible. Add the coefficients of the like terms and keep the variables and the radicals the same. We'll start off with example 1, the square root of 36x plus the square root of 25x minus the square root of 49x. Now, the square root of, you see this is x to the first power and this is x to the first power. 2 won't go into 1. This is going to have to stay in the radical every time. But we can break down the square root of 36. It's 6, so we have 6 square roots of x. The square root of 25 is 5 square roots of x. Square root of 49 is 7 square roots of x. The square root of x has to stay under the radical. 6 square roots of x plus 5 square roots of x would be 11 square roots of x minus 7 square roots of x, which would be 4 square roots of x. Example 2. Now, the square root of x squared, the square root of x squared, and the square root of x squared. Anytime I have the square root of x squared, 2 goes into 2 evenly, and it will come out and become x. So I think I'll just take care of that right off the bat. 3x square roots of 8 minus x square roots of 50 plus x square roots of 18. And then I'll use my program to break down those other three. So I have 3x times whatever the square root of 8 gives me. Square root of 8 gives me 2 square roots of 2 minus x. What does the square root of 50 give me? Square root of 50 gives me 5 square roots of 2 plus x. And what does the square root of 18 give me? Square root of 18 gives me 3 square roots of 2. 3 square roots of 2. So I have 3 times 2 is 6x square roots of 2 minus 5x square roots of 2 plus 3x square roots of 2. 6 minus 5 is 1x square roots of 2 plus 3x square roots of 2. And when I add the coefficients, 1 plus 3 is 4, so I have 4x square roots of 2. Now in this problem, you see I have an x squared again. Oh, I just have 1x squared. Okay. So I'm going to have to break the square root of x squared. It's going to become 5x, but I will have to break down the square root of 75 minus 2x square root of 12 plus 3x square roots of 48. So I'm going to use my program on the calculator. I remember doing 75 today, but I forgot what it was. Square root of 75. 5 square roots of 3. So I have 5x times 5 square roots of 3 minus 2x. Now I need to do the square root of 12. Square root of 12. 2 square roots of 3 plus 3x. And I want to do the square root of 48. And that's 4 square roots of 3. So now I have 5 times 5 is 25x square roots of 3 minus 4x square roots of 3 plus 12x square roots of 3. Combining the coefficients, 25 minus 4 would be 21x square roots of 3 plus 12x square roots of 3, and 21 and 12 would be 33x square roots of 3. Last example. Now this x squared is going to stay underneath the radical, and so is the y squared, because if I try to do the cube root of x squared or the cube root of y squared, you see that 3 doesn't divide into 2 evenly. 2 is smaller than 3. So basically, I'm going to leave the x squared underneath the radical. I'll have 3. I'll have to break down the cube root of 16, and that cube root of x squared is going to stay underneath the radical. Then I have 2. I'll have to break down the cube root of 54, and that y squared is going to stay underneath the radical. So let's see. Cube root of 16 2 cube roots of 2. So I have 3 times 2 cube roots of 2 times the cube root of x squared plus 2 breaking down the cube root of 54 gives me 3 cube roots of 2, 3 cube roots of 2, and then the cube root of y squared stays underneath the radical. So now I have 6 cube roots of, these have to be put back together underneath the radical, 2x squared plus 2 times 3 is 6 cube roots of 2y squared. And that's all you can do that because the radical parts are not alike. The radicands are not alike. I cannot add these together because one of them is x squared and one of them is y squared. This has been section 14.2. You will need to do the homework on this section. You will need to do the quiz on section 14.2. This is Jo Karen Hudson. Thank you and have a lovely day.